Today we're going to talk about molar mass, which is a concept, it's a value that gives us a useful conversion between the number of molecules that we have and the actual mass that we can measure in the lab. The molar mass is the number of grams that 1 mole of a particular atom or molecule would weigh if you were to put it on a balance in the lab. And so the place we find this number is on the periodic table. So if we were to look at carbon on the periodic table, for example, the number on the bottom that we've referred to as the atomic mass is 12.011. That number is how many atomic mass units one atom of carbon is, and it is also, it turns out, the number of grams in 1 mole of carbon. Okay, so the atomic mass, or the molar mass for carbon is 12.011. Okay, grams per mole, it's important to include the units. All right, so we can use this as a conversion factor also. So we could also write it as 12.011 grams of carbon over 1 mole of carbon. All right, and we're going to use these conversion factors later on in this lesson. All right, so if we do the same thing for hydrogen, if you look at your periodic table, hydrogen is 1.008, and that's going to be grams per mole for the molar mass. Iron is also on your periodic table. It's 55.933 grams per mole. Okay? And the molar mass of molecules you can get by adding up the molar masses of all of the individual components. So if we go back to our cheese sandwich example, if you wanted to know how much one cheese sandwich weighed, you could also add up the mass of 2 slices of bread plus 1 slice of cheese, and that would give you the mass of the sandwich. So if we look at an example for the molar mass of water, which is 2 hydrogens and 1 oxygen, then we would take 2 times the molar mass of hydrogen, which is 1.008 grams per mole, plus 1 times the molar mass of oxygen, which is 15.999, and then when we add those together, we get the molar mass of water. Now we're just going to do a few more examples. So first we have lithium carbonate, and this is a good chance to practice naming we just learned. So lithium carbonate has 2 lithiums, so we want to do 2 times 6.941, which is the molar mass of lithium, plus the molar mass of carbon, which is 12.011, plus 3 oxygens, so 3 times 15.999, and that gives us 73.89 grams per mole. Okay, now sodium chloride. Sodium is 22.990, and chlorine is 35.453. When we add those together, we get 58.443 grams per mole. And then finally, magnesium nitrate. So this one is a little trickier because it's got parentheses, but you want to treat that the same way that you would in math. So I tend to like to distribute the number that's on the outside, but you could also calculate what's in the parentheses first and then just multiply that by 2. So the mass of magnesium is 24.305, plus we have 2 nitrogens because we have a 2 on the outside, so when that comes in, we know we have 2 nitrogens, so 2 times 14.007. And then there's 3 oxygens on the inside and then a 2 on the outside. We would multiply those 2 numbers when we distribute. So it's going to be 6 times 15.999, which is the mass of oxygen. And when you add all that together, you get 148.313 grams per mole. Now that we're really good at calculating molar masses and finding them on the periodic table, we're going to use them as conversion factors to help us solve problems. So I have a few steps here for helping you figure out how to solve a problem that uses molar mass, or using molar mass, and we have an example here. So our example is silver metal is used in the manufacture of tableware, mirrors, jewelry, and dental alloys. If the design for a piece of jewelry requires 0.750 moles of silver, how many grams of silver are needed? Okay, so the first step is to identify the given and the unknown. So what we're given is 0.750 moles of silver, and what we want to find, our unknown, is the number of grams of silver. Okay, so then we need to write a plan. So we want to get from moles to grams, and the way to get there is molar mass. Okay, and so in the case of silver, the molar mass is 107.868 grams. And remember I said we can write this as a conversion factor, so that's grams of silver in 1 mole. So we can write 107.868 grams over 1 mole. Okay, then the next thing that we want to do is set up the problem and do our conversion. So we want to start with what we're given out front always. So that's 0.750 moles of silver. Okay, and then we want to make sure our conversion factor is written in the right way to get our units to cancel. Okay, and I happen to write it in the correct way here. Remember where we want to go, what we're trying to find, that unit always goes in the top. So we want grams in the top, and where we're starting with, we want that to go on the bottom so that our units cancel. So that would be moles in the bottom. Okay, so our moles cancel out. The only units we're left with are grams of silver, and so we do 0.750 times 107.868 divided by 1, which is equal to 80.901, and that's grams of silver. And it's always a good idea to go back and double check that your answer makes sense. So here we have a little bit less than 1 mole of silver. So we would expect that our answer is going to be a little bit less than the number of grams in an entire mole. And so our molar mass is 107, and we got an answer that was about 80. So that makes sense. And so we probably set up our calculation correctly. Now let's do one more example. This time we're going to go from grams to moles. So our problem is a box of salt contains 737 grams of NaCl. How many moles of NaCl are present in a box? All right, so first we have want to identify our known and our unknown, or our given and our unknown. So what we're given is 737 grams of NaCl, and what we're trying to find is the number of moles of NaCl. So we want to make a plan to get from grams to moles, okay? And in order to do that, we're going to need to use the molar mass. And we just calculated the molar mass of NaCl as 58.443 grams, and we can write that as over 1 mole, because that's the number of grams in 1 mole of sodium chloride. Okay, so now we want to, we have our plan, we want to set up our calculation. So we always start with what we're given. So we write 737 grams of NaCl, and then we're going to do it times our conversion factor, right? And remember where we're going, we want to put in the top, and what we want to cancel out should go on the bottom. So we're starting with grams, so we want grams in the bottom. So we want 58.443 grams down here, and we want 1 mole in the top up here. All right, and when we multiply or divide that out, we get 12.6 grams of NaCl. Now we want to combine what we learned in our last lesson about how to get from moles to atoms, which we would do this way, or from moles to molecules, and we're going to combine that with what we just learned about getting from grams to moles, either in terms of an element or in terms of a compound. Okay, and we'll talk next time a little bit more about getting from moles of an element to moles of a compound. We'll do practice problems of those in class, but that's similar to what we did with the water molecules. We find out how many moles of water, and then we can figure out how many moles of hydrogen we have, for example. So the example we're going to do in class today is a 10-pound bag of sugar contains 4,536 grams of sucrose, which is C12H22O11. How many molecules of sucrose are present? So the first thing we want to do is identify what we're given, and so that's the grams of sucrose, and what we're trying to find, and that is our unknown, which is the molecules of sucrose. Okay, so in terms of our flow chart up here, we're going to be going from grams of a compound to molecules. All right, so we're going to be using these 2 arrows in our flowchart. So this is basically the plan that we usually make. We know we're going to need the molar mass, and we know we're going to need Avogadro's number. Okay. So the first thing we're going to do is calculate the molar mass. So if we do 12 times 12.011, which is the mass of carbon, plus 22 times 1.008, which is the mass of hydrogen, plus 11 times 15.99, which is the mass of oxygen. We get our molar mass for sucrose, which is 342.297 grams, and that's per 1 mole. So now we want to go ahead and set up our problem. So we're going to start with what we know out in the front. So that's 4,536 grams of C12H22O11. And we're going to multiply that by our conversion factor for molar mass, because that's our first arrow here. So we need to determine what goes in the top and what goes in the bottom. We're starting with grams, so that's what we want to cancel out. So we're going to put 342.297 grams in the bottom, and in the top we're going to put 1 mole. And now we want to use Avogadro's number to get to molecules. And we know that 1 mole is 6.022 times 10 to the 23rd molecules. Right, so we want moles to cancel, so the 1 mole is going to go on the bottom. And on top, we're going to put 6.022 times 10 to the 23rd, which is how many molecules we're going to have. Right, so if we set that calculation up in our calculator, we get 7.980 times 10 to the 24th molecules of sucrose. And now we're going to build on this in class tomorrow and do lots of practice. So for example, we could have taken this problem and figured out the number of atoms of carbon that were present if we had continued up and used this arrow to go up from molecules to atoms, and knowing that there are 12 carbons in 1 molecule of sucrose. So those are the kinds of problems that we're going to be working on, and really getting to know this chart and being able to do these problems without looking at the chart eventually.